Let's look at finding the domain of a rational function. The domain of a rational function must exclude any numbers for which the denominator might equal 0. This can be found by setting the polynomials in the denominator equal to 0 and solving for the variables. These variables are where asymptotes exist for those or these rational functions. If you have a quadratic, you might have to factor it here, and we need to find the domain of each rational function. The numerator will give us zeros of the polynomial, and the denominator will give us vertical asymptotes. If I take the denominator and set it equal to 0 and solve for x, I get x is equal to 5. This gives me the vertical asymptote. I'll abbreviate it as VA at x equals 5. This gives us a restriction. This is the value of x that cannot be included in the domain. So my domain is all real numbers except that. I will write it as -infinity, comma, 5, close parenthesis, union, open parenthesis, 5 to infinity, close parenthesis. Now let's look at g of x. In the numerator, we have x minus 3. This means there is a 0 at x equals 3. Meaning it crosses the x-axis at 3, the function does, and the denominators have vertical asymptotes. At x minus 2 equals 0, and at x minus 5 equals 0. If I solve for x, I get x equals 2 and x equals 5. These are my two solutions. So I have vertical asymptotes at these two values. Everything else is fine. Like you can have values of x everywhere else. Any other number you put in there will not give you an undefined denominator. So these are my only restrictions on the domain. So I'll go ahead and list my domain in interval notation. Starting at the leftmost side, I have -infinity, and then 2, close parenthesis, union 2 to 5. That's my next interval, going from smallest to largest. Union, open paren, 5 to infinity, close parenthesis. Now let's look at h of x. h of x is 5 over x squared minus x minus 6. This is not factored, so I'm going to try to factor the denominator first. And it doesn't look like there are any obvious roots or zeros of the polynomial. It just looks like there are these two vertical asymptotes. I'll factor this trinomial to an x and x, a -3 and a +2. That will give me a negative middle term of -1 and a negative final term of -6. If I set these equal to 0, I'll have my two vertical asymptotes. X minus 3 equals 0, and x plus 2 equals 0. Solving for x, I get x is equal to 3, and x is equal to -2. These are the restrictions on my domain. This is where the vertical asymptotes exist. So I must throw those values out, starting from the leftmost value, starting at -infinity, open paren -infinity, comma, -2, close paren, union, negative 2 to 3, close paren, union, open paren, 3 to infinity.